Hello everybody, let's solve this problem. In this problem we are asked to calculate the DC operating point. So this is your NMOS circuit. So by looking at this arrowhead represents that it is a N channel enhancement type MOSFET. So here this is your drain and this is your source and this represents your gate. This represents voltage divider biasing. So in order to find out this Q point or the DC operating point, we need to find out this ID, that is the drain current, and this VDS, that is the drain to source voltage. To find ID, the formula is ID is equal to K into VGS minus VT the whole square, where this K is the transconductance parameter, and for the NMOS it can be represented as Kn. And this VGS is what? VGS is gate to source voltage. So where do you actually represent this gate to source voltage? This one, right? This is your VGS. And this VT is threshold voltage. VT is the threshold voltage. It can also be written as VTH. So once you know this parameters, now we can try to substitute all these things. So to find ID, this K value is given here itself. So it is 0.1 milliamp. So we can write it as 0.1 into 10 power minus 3. It is 0.1 milliamps per volt square. So it is 0.1 into 10 power minus 3. Then VGS value that is not known to us, we need to find it out, minus VT or VTH, that is given as 1 volt the whole square. So if you know this VGS, then only you can calculate this ID. So how to calculate this VGS? In order to calculate this VGS, we have to find out this potential VG. So to calculate this VG, we use voltage divider rule, VDR. So how to do this? So this is the network in which we are going to calculate this VG. So the formula is, to find VG, it is the supply voltage VDD, which is available here at this point, this 10 volts, multiplied by VG means from here to here it has to be calculated, isn't it? This is the voltage across this R1 resistance. So it is VDD multiplied by this R1 resistance divided by the total resistances R1 and R2. Total value of the resistances R1 and R2. So here VDD value is 10. So 10 multiplied by, so this is equal to, VDD is 10 multiplied by this R1 value is 20 kilo ohm divided by R1 plus R2. So it is 20 plus 30 kilo ohms, 10 power 3. These two can be cancelled out. So it is 10 into 20 divided by 50. This 0, this 1, 4. So this VG is 4 volts. So we have calculated this VG as 4 volts, which is the voltage across this R1 resistance. But we need VGS, isn't it? So how to calculate VGS? VGS using double subscript can be rewritten as using single subscript as VG minus VS. So what is this VS? VS, this is your source point from source to ground, that is called VS. But this S is, the source is directly connected to ground, so this value is equal to 0. So this becomes 0. So VGS is equal to VG only. So this value is 4 volts. So once you got this 4 volts as VGS, that can be substituted in this equation of ID. So this is equal to 0.1 into 10 power minus 3 multiplied by this 4 minus 1 the whole square. So this is equal to 0.1 into 10 power minus 3 to 3 square is 9. So that is equal to zero point 0.9 into 10 power minus 3. So ID value is equal to 0 0.9 milliamps. So it is 0.9 milliamps. So we got one answer. This is one answer. Now we need to find out VDS. So how to find out this VDS? What is VDS? VDS is drain to source voltage. That is, this one is D drain, this is your source, in between existing voltage, which is our VDS. So to calculate the operating point, VDS is also required. So how would you actually calculate it? For that, we need to write the KVL, Kirchhoff's voltage law, at the output side. So that starts from here. So that ID current flows through it and it ends here. ID is the drain current, right? And this ID current and the source current will be the same. That you should know. Now we can write this KVL. So it is VDD minus, when this ID flows through this RD, you will get it as ID RD as voltage drop, ID into RD, and across this you will be getting minus VDS, and then it would be equal to 0. Now we can substitute the known values here. VDD is 10 ohms minus ID value is already calculated as 0 0.9 milliamps, so it is 10 power minus 3. RD value is given here as 2 kilo ohms, so it is 2 into 10 power 3 minus the VDS is the unknown, which is to be determined, that is equal to 0. So it is 10 minus, these two can be cancelled out, 10 power minus 3 and 10 power 3. It is 1.8, isn't it? Minus VDS, that is equal to 0. So this value is 8.2, that is equal to VDS, or you can write this as VDS is equal to 8.2 volts. So this is the required second answer. So we got the Q point now. So what's the Q point? Quiescent point, or the operating point. It is the DC operating point. So there we got this ID as 0.9, 0.9 milliamps. And what is your VDS? Drain to source voltage. That is 8.2 volts. The another thing is we need to check out. Actually, we have done everything based on the assumption that this particular MOSFET, NMOS FET, is working in the saturation region. So we assume this. After that only actually we need to do this. So in the saturation region, actually VDS sat is to be calculated. For that, the formula is VGS minus V threshold. VDS sat is equal to VGS minus V threshold. So VGS value is calculated as 4 volts minus this VTH is given as 1 volt in the problem itself. So it is 3 volts. Now we need to compare this VDS sat with the VDS. If VDS value is greater than VDS sat, we check it out now. VDS we have calculated as 8.2 volts. So definitely it is greater than this VDS sat value of 3 volts. Okay, so this condition is satisfied. VDS is greater than VDS sat. So that our assumption is correct. Now this NMOS is working in the saturation region. It is in saturation region. So our DC Q point is also correct. Okay, the selection of Q point is correct. So our answer is this one. This is our answer. Okay, thank you. Hope you have understood.